we don't have the time for the x formula, we're going to have to use the y formula. Now remember that the y formula goes a little something like this. Y is equal to your initial height plus your velocity, initial velocity times the time, plus 1/2 gravity times time squared, right? So then, let's go ahead and look at it. First off, what is the final height of this bale of hay? It's 0, because it ended up on the ground, right? So we know that, fantastic. What is the initial height of this bale of hay? It's 100, because it was like 100 meters tall, right? 100 meters, there it is. Now, here's the rub. Right when this thing was about to fall down, what was its initial velocity in the y direction? Now that's not stated, and I don't blame you if right now you're kind of scratching your head thinking, well, we don't know how fast it's going on the trip down. But imagine that you just barely launched this bale of hay out. It just became a projectile. There's going to be a moment where if you take a perfect picture, it's looking like the bale of hay is floating in midair. The initial velocity in this case is 0 meters per second. Now you say that doesn't make sense. It started falling. Yes, it started falling after it's pushed out of the plane. But there was a tiny second where it was just floating there. So then this whole thing just becomes 0, right? And so I don't care about the time. Okay? Now why don't I care about the time, Mr. Mian? Because anything times 0 is 0. So I don't care. If velocity is 0, then I don't care about the time. And now let's put 1/2 gravity. What is gravity? We know that it is 9.81 meters per second squared. And time is over here on the outside. But guess what? That's what I'm looking for right now so I can solve my problem. So all you have to do is a little bit of algebra. Go ahead and solve for time, which means grab everything that's not a t, move it to the other side of the equation.